Hey, we're back with the ATTIny console project part 2. Hopefully I can finish it in part 2. All right, so I've already done some changes, but I'm only just now documenting them. So before, if you recall, we had a interrupt service request that was drawing everything. And I didn't really want to do everything in there. So I was looking around. It's a register that holds the bits for the timer results. Ah, yes, TIFF row. So this is where the flag gets set if the comparison happens. Now, obviously a relay would also be triggered, but if we don't want to trigger a relay, we can actually just look for this bit. You know, running things inside of a interrupt is kind of janky, but on top of that, the interrupt does a lot of pushes and pops of the stack, which takes up quite a bit of RAM, and if we can avoid that, we should. We're still using the compare A register. So if we take the TIFF row thing, and we see that compare A is the second bit. So when that gets set, that means the counter has reached its destination. So inside of our main while loop, we can do another while loop, while not TIFF row N2. So we're basically just waiting for that to be set, which kind of acts like an interrupt. However, we're not having to pop and push the stack. Okay, for those that don't know, in assembly, which is what this eventually gets, compiled into, when you jump to an interrupt, it basically interrupts whatever you're doing. So it actually takes all of the registers that are in the CPU, which we'll talk about here shortly, and it copies them to RAM as a backup. And then once it exits the interrupt, it copies them back into the registers. And that's probably not a big deal on larger processors, but it's kind of a big deal here, especially because we don't have very much RAM, and that also takes a lot of time. So let's not use interrupts. All right, so we're going to actually just do it right here. So I took someone's advice from the comments of the last video, and yes, you can do video with just one pin. So we're using all three states of the pin. So low is the sync, high is white pixels, and tri-state, or having the pin be an input, is the black level, which is set by the voltage divider. It takes a little bit more code because we have to do we have to do a few more statements, but it saves us a precious pin, which is the most precious resource of all. Now you see here we're using SMCR, right? So also, the suggestion I saw was using whatever registers you can as RAM, as long as you're not using them. So that's the sleep control register. So the first bit of it, or bit 0, that actually enables sleep. But the other 3 bits, that's the type of sleep. But if you don't enable sleep, it doesn't matter what those bits are set to. So we can use those to store 3 entire bits of data. And in this case, we're using bit 2 as the VSync flag. There's another register we're not using, the external interrupt control register. Erica, whatever. That gets us 2 bits, but that's enough because what I want to do, I only need to count to 1. I want to save a byte and have line counter only be a 1 byte value. So what I do is I divide everything by 2. So instead of going to 256, we trigger it at 128. And then we actually just increment the Erica. I'm just going to call it the Erica register. We increment the Erica register. Basically, we increment it, and then we see if it's odd or even. If it's odd, then we actually increment the line counter, which means these things will only happen every other line. And the reason we put this check here is so you don't do the same thing twice in a row. It'll set up conditions just once, I guess is my point. Have this if line counter equals bug next, and that's how I'm going to be drawing the enemies because I'm thinking Space Invaders, but we'll get to that in a minute. A variable called sections. So we're going to have enemies, the barrier, player, and then nothing. So there'll be another switch case that actually decides what to draw based off of this. So I'm basically separating the vertical screen portions with this variable and then putting it into the main draw routine. Then of course we have the VSync, which we do by setting the second bit of the sleep register. This is the digital input disable register because you have to enable that on the ADC for it to work. But that's like 4 whole bits, so we could use that to count some other things. And it doesn't matter, as long as it's in the right setting when we need to read the ADC, we can use it for other things when we're not reading the ADC. Haha, great. Yeah, so anyway, now we fit that into 1 byte, so that's cool. The line counter, I mean. So the bugs, right? So the bug next is the line on which we're going to draw some bugs, and that can be reset, right? And we're actually going to use yet another register to count the vertical sprite line number. This is the pin change mask register. So this is like, oh, is an interrupt going to happen if the pin changes state? But we're not using it, so there's 4 bits we can use, which means we can count from 0 to 15. We're only going to count from 0 to 7. So we actually use that as a trigger to start drawing a sprite, and we kind of did that in the previous video as well. Yeah, and then we're using did R0 to count how many lines of bugs to draw. I think I'm going to do about 5 rows of bugs. Yeah, so basically we're using registers as RAM because they are RAM. Memory is RAM! So we need to think of these line counters as being halved, which means 21 is actually line 42. So between line 42 and 180 is where the enemies marching down on the player can be drawn. And that will set section to number 2. So right after we do the VSync, which I think I could speed up some more, but this will work for now, we have a switch section here, and this is what to draw on the screen, right? Depending on what line we're on. So at this part, we've just started on the left-hand side of the screen. So we have to draw one line of pixels from left to right. What do we draw, right? So are we drawing the bugs? So the question is, okay, we're in the bug section of the screen, but that doesn't necessarily mean we're drawing the bugs because we have to be in the right vertical position for the bugs to, to appear. That's why we have bug next. Bug next is the next line on which to draw bugs. And the reason we have like the bugs vertical position and bug next is because we have to draw multiple lines of bugs or rows of bugs. So what we're doing earlier in the frame, well, we sampled the ADC, we'll get to that later, but I'm doing bug mask as a variable. You'll see the point of that in a bit. So after we read the ADC, then we can use the digital input disable register for something else. For instance, to count how many rows of aliens we want to draw. So I guess that's rows, not lines. Bug next equals bug V. So bug V is the topmost vertical position of the aliens. And then once you set bug next to be something, then it'll start drawing the aliens. So if you look back here in line counter, if we reach the bug next position, we set this register to 0, and that is the sprite line counter. And then we also shift the bug mask. We'll get to that later. But then we take this value, which if you remember we made it 6, and then we decrement it. And if it's not 0, we increment bug next by 10. So we'll draw 8 pixels vertically of bugs. Then we'll skip 2 pixels, and then the line counter once again hit bug next because we plus 10'd it. And then we'll draw another line of aliens. Unless, of course, they've been blown up by the player. But that's a different story. We'll get to that later. Drawing the bugs, right? So are we in the right portion of the screen to draw the bugs? Okay, so if PCM, whatever that register is, who knows? Single people might eat crackers. We don't know. Frankly, we don't want to know. If it's less than 8, which means it's been triggered by becoming 0, so we're going to need some sprite data. So we have bug graphics, which is what the bug itself looks like. And it's split into 2, but he's going to have like an eye and an arm and some legs. And then we have the other one, and this is actually the bit mask that describes how the bugs are drawn in the screen, like, their attack formation. And I'm doing it in such a way so I can, see the change. That's why I don't have it all solid. But when the game's actually running, it would just fill these all up, right? Because all the bugs are there. Okay, so back down here. If PCM blah, blah, blah is less than 8, okay, are we going to draw bugs? Okay, cool. So we need to get the bug graphics. We got that from bug graphics. So what I'm going to do is I'm going to create a local variable, which should go into a register and save us some RAM. Sprite line equals bug graphics plumask, right? Which is going to be from 0 to 7. That will grab one of these lines. So for 0, 1, blah, 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 7. So that's how we, draw it in different, we did that kind of in the last episode. This is just a little bit more advanced. And then we'll see what register it goes into. The last time I tested it was register 24. Again, we're going to talk about that very soon. Then we need to waste some time for the horizontal position. Again, we did this before. I've got bug H for bug horizontal. So bugs across is how many bugs we're going to draw from left to right. Okay. So if there's bugs in this particular row, and the first time I tried this off camera, I was doing it. So these were our bit defined. So it was drawn on the screen just like it is here. So here's the top row. Here's the left bug. Here's the right bug, blah, blah, blah. But now I'm doing it a little differently. It's actually, so this is the leftmost column, and then this is the highest bug and the lowest bug, and then this is the rightmost column with the highest bug and the lowest bug. And the reason I did that is because it's actually less math to figure out what bugs are there or not. And so what we'll do is we'll basically, for each line, because remember these are the rows of bugs, we'll see if the bit is there, and then we'll draw the bug, or we won't draw the bug. So on each line, we're going to look at each segment of this array, right? Then we're going to say, okay, is there a bug here? Is there a bug here? Blah, blah, blah. And then for the next row of bugs, bug mask will shift one to the right, so we'll be comparing this, right? We're going to drop to 6 bugs, but for right now I'm only going to draw 2. So I'm using a do while here because it's actually more efficient code-wise than a for int next type loop. And everything in this will always happen at least once, regardless of this condition being true or not. Okay, so if there is a bug there, then we're going to take bugs, bugs across, and bug mask, which starts out as, oh yeah, right there. And there's a reason I did that. See how bug mask gets bit shifted 1 to the right when you start drawing the bugs? So I start it here, and then it gets bit shifted, which puts it there, which is where we actually want it to be. And we do that so we don't have to mask it later. We're basically making this as efficient as possible. Okay, so if there is a bug there, draw the sprite, which we did in the previous video. Else, just write a bunch of zeros to the screen. Then what we're doing is we're using that same line doubler down here. So if the line doubler is positive, we will increment the sprite counter. Otherwise, this will basically make it draw each vertical line of the sprite twice, just like everything else on the screen. Okay, so we have 2 columns of invaders and 5 rows. But see how chunky they are? And that's because we're doing all this stuff in draw sprite. How can we make this better? It's impossible, right? Well, this chip doesn't have a debugger. It's just too wimpy and small, but it does have a simulator. So I can go over to simulator and hit debug start. Look at all this stuff. We can see the memory. We can see the registers of the CPU. So that's basically RAM on the CPU, which is actually faster than the RAM elsewhere on the chip. It might seem like it's the same thing, but it really isn't. This is much more akin to the registers on a classic CPU. Let's run to cursor. So I'm going to run the code to here. Okay, so this is the draw sprite routine, and this is the disassembly of it. Load immediate. DDRB equals 1. And then it actually shows you the C code and then what it becomes. See, skip bit if register is set, relative jump. That's because of the if-then statement. We're bit shifting the data to 1. Logical shift right. Okay, looks like it put it into register 24. Okay, so we'll go over here, register 24 CC. All right, that makes sense. All right, so it put it into register 24, and then it does all this stuff, and it just takes a while. How can we make this faster? Well, you see we've inserted our own assembly using this ASM volatile thing. Volatile tells the compiler not to remove it. LSR, logical shift right, register 24. Let's do something else. Let's go down here. Again, it's paused right now. Let's run cursor or run the program to cursor at draw sprite line. This is where it actually jumps to it. Okay, load indirect with displacement, logical and where is it? Load indirect with displacement. This one's a lot more straightforward where we just draw sprite 0. Load 0, 0 immediate, which means it's just the actual value 0, 0, not memory location 0, 0. Into R24, and then we call the subroutine. All right, so R24. All right, what I'm about to do will make some of your blood boil. Well, it'll make someone's blood boil. I'm sure some of you already figured out what I'm going to do. As we mentioned before, we actually make it go white or black by just changing the direction of the data direction register. Yeah, so that's going to be memory location 1. All right. So we want to go out to memory location 1 with the contents of register 24. Yes, please forgive me. I know not what I do. Oh, what am I talking about? I know exactly what I'm intending to do. I wouldn't say I know what I'm doing per se, but I definitely know what I'm intending to do here. All right, so when we call this function, the assembly is passing the data, this local int, in register 24, and that's one of the ways that it saves you RAM because it's actually putting a lot of those locals into a register. And as we can see over here, yeah, this register, 24 has CC in it, and most of the registers are being used, so we'll probably try to avoid them. Oh, also over here, we can look at the, where was the timer counter? Yeah, there's a TIFF row right there, see that? So those are the bits we were looking at. That's bit 1, that's when we actually compared it to. Logical shift right, register 24. So what this is going to do is going to put register 24 into the data direction register, but the only thing we're really caring about is the lowest bit, the LSB, because that's actually what gets clocked out to the screen. So we're gonna clock the pixels out one by putting them into the data direction register. Then we shift the register, so the next pixel over is now in the LSB position, and then we do it all over again. Now, the thing that's nice about this is we'll know exactly how long it takes, which will be, well, it'll be one cycle per instruction. Well, of course, we had the DDRB at the end there. Now, I'll just leave that there for now. It's not the most efficient, but it should work. All right, let's try this on the real hardware. Whoa, look at that. They got way, way smaller. We are basically drawing these pixels as fast as we possibly can, but it's got some pretty good detail. Now, if you notice, the character looks split in half. And there's a reason for that. It's because I set up the data so we use 4 bits for each frame of animation. So we can actually draw the character. We can basically actually mirror the character, and that way by using one nibble or the other, we can actually create some rudimentary animation. Actually, let's do that right now. I'm going to use rotate right instead of logical shift right. The reason for that is rotate will actually cause the LSB to carry over to the MSB and vice versa. That way we don't actually destroy the contents of the register like we do with the shift. So we'll do the first 3 the same way. So we're going to draw pixel, 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 pixel. But then the middle pixel, since we're mirroring it, we want to draw twice. So we'll just put it in a NOP so it takes the same amount of time as everything else, right? Then we'll draw the same pixel again, whatever that lowest pixel was. And now we're going to rotate left, right? So it's going to be rotate left like that. So we'll just change that. So we actually only need to draw 3 more pixels since we drew the 4th pixel twice. Rotate, rotate, rotate. Yeah, okay, so 1, 2, 3, 4, double the middle, 1, 2, 3. So we're drawing 8 pixels. We're just, drawing them mirrored basically by just changing the direction in which we rotate the bits. And again, this doesn't cost us any extra operations. But with this processor, if you did something like DDRB bit shift equals 4, in assembly, it would actually have 4 rotate instructions. Whereas more advanced processors, which is pretty much any processor in the world, would just do this in a single operation. So that's something to think about. And in lieu of this DDRB, which actually would load a register from memory, well, like if you look at like this DDRB here, right? If you look at this C command, DDRB equals 0, this is what it's doing. It's like load 0 from flash into register, copy register into DDRB. Okay, I guess that's not too bad. But, that takes up it takes up 2 bytes of flash, or 1 word. So we could just do it like this. Okay, so after we shift out the last bit, then we'll logical shift left R24, which will destroy the LSB. It'll always be a 0. Then we go out again, and that's how we clear the pixels on the end. Oh, the sleep register. Well, we're only using 1 bit of it. Let's use another bit of it. How about bit 3? All right, so let's go here. So we've loaded the bug graphic into that local int, which we now know goes into register 24. Now that could change, but it probably won't, but we'll keep an eye on it. So if SC, whatever that is, if that and 8, so if that bit is set, else that. All right, so remember when we talked about the, so remember how earlier we had 1 frame of animation per nibble? So we can bit shift the sprite line graphic 4 to the right, which again will take 4 operations, and that will show the other half. This will give us our frames of animation. However, if we don't do that, we have to make up for the fact that sprite line consumed time, right? So we're going to need some NOPs. All right, we're going to need 3 of them. And you might be thinking, oh wait, that's 4 instructions to do 4 bit shifts. Why are there only 3 NOPs to take up the same amount of time? And that's because depending on if you're in the if or else of a statement like this, one will actually execute faster than the other and take up fewer cycles. And that's how accurate and close everything is with this. It's pretty hardcore stuff. So I have move count and move speed. I got to waste 2 bytes, but you know, that's life. That's going to be the speed at which the bugs move. So let's just find a place down here. VSync pulse on. Yeah, sure, why not? We'll do it here. Let's see. If plus plus, as long as we can do this in like, what, 400 clock cycles, it's okay. So if move count equals move speed, that means the critters are going to move. And of course, we want them to move faster as time goes on. SMCR plus equals the bit mask. Now, the reason we do that is, well, here's why we do that. If we go to, oh, where is that stupid thing? SMCR, there we go. Okay, so we're altering bit 3. So if we add bit 3 to bit 3, it's either going to carry into 4, who cares, or it will create a 0 here, which means, yeah, we don't have to do any bit masking. We just add its own value to itself, and that will create a counter starting at bit 3. So that's something easy you can do. You can basically, if you think about it, you can actually create like a binary counter at any point in the byte, depending on where you load things in. Yeah, of course, obviously, we'll want to reset move count. And unlike Cyberpunk 2077, this will be locked at a solid 30 frames a second. So if we set move speed to 30, the bugs will move once a second. Hey, look at them go. They're doing a little bug dance. Let's get physical, physical. Right? It's like this is what an Olivia Newton-John Atari video game would have looked like. You know, now that our bugs are skinny after doing all those workouts, we can change, where was it here? Oh yeah, we can change this. Let's make this 6. We'll make it kind of like the Atari 2600 version. I guess we could do more, but oh wait, no, because we only have 6 lines in that code. So boom, there. Now we have 6 of them. So remember, it's byte, 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 byte. Okay, let's make some more screen areas. I'm gonna go case 5, ground, break. This one's really easy. DDRB equals 1. Just draw white pixels for the ground. Remember, so there's 2 switch sections. There's the one that draws the pixels. So you could consider this the horizontal switch section. And then there's one that decides what section we're in based off the vertical line counter, right? So in this case, let's see, where would section 5 be? Okay, yeah. Right, so we'll start section 5 at line, will it be 230. There's some ground, easy as pie. Barriers, we want those barriers between the enemies and the player. We could do 4 of them. Let's see, 4 of them. If we packed it into a byte, that way, yeah, maybe we have 4 barriers and they each have 4 hit points, so to speak. So we could define each barrier with 2 bits, which would each give them 4 levels of health, so to speak. So yeah, we set up barrier FF, so just all 1s. Just easier that way. Let's call that section 3, so it's right after the enemies. So down here, so we have where the enemies start being drawn at line, well, 21/42, whatever you want to call it. And the barrier will be 90. Okay, so this is the data for actually drawing the barriers. You also notice I immediately have an assignment here. Barrier temp equals barrier. In switch case, you actually have to add a semicolon after the colon in the case if your first statement is an assignment like this. Just fun fact. So I'm going to delay some time to start it off from the left-hand side of the screen. I'm going to draw 4 barriers with a space of delay 4 microseconds between them each. All right, so if barrier temp N3 is more than damage, then we have pixels drawn, else we don't draw pixels. Okay, well, I need to also stop drawing the barriers. Oh, you know what the problem is? I need to draw the player area. Right, because, oh yeah, because section 3 just kept going, see? Because section 3 didn't stop until it got to section 5. So I needed to find section 4, which is where the player is drawn. I'll do that next. Go in here, and even if we don't do anything with the player section, we'll go case 94, section equals 4. So the barrier is only going to be like 4 double pixel heights. So even though we don't have anything drawn, or we don't have anything programmed for the player area yet, this will prevent the barriers from being too tall. Let me just show you real quick. I'll just flash it over. And there you go. Okay, so yeah, you see where the barriers stop. And now this will be section 4, which is where you need to draw the player, which I guess we should do next. VCC level monitoring control and status register. I mean, I guess that's kind of cool, but I don't really need it for anything. But look at these 3 delicious bits here. So I guess the lower 3 bits is what kind of flag is set. Well, we can give it a shot. Ah, what's the worst that could happen? Yes, section variable. I'd like to refractor you and make you something else. You're going to be a system register now. It'll change everything automatically. Oh yeah, no problem. We can totally use the leveling monitor control status register to keep track of which section of the screen we're drawing. We saved 1 byte. Speaking of which, let's see. So we've used 16 bytes and 57% full of the flash. It's pretty good. I was hoping to be at about 50-50 before I got to game logic. Oh, the memory too. I mean, we could probably find some more. Oh yeah, the non-volatile memory read-write register. So this register would be used by the programmer actually to flash the chip. But look at this. 6 juicy bits. Oh yeah. Sounds good. Well, 6 bits would get us what? Like 63? Yeah, so let's do the same thing. I'm going to refractor this. I'm going to take all instances of move count and change it to that register. It still works. Because if you check the data sheet, if you RTFM, this chip can't program itself anyway, so who cares if we use that register? Then what I could do, I think I could do it in 4, honestly. Yeah, it's like you're small, right? Like you are insignificant compared to the bugs. Yeah, same thing. So if I'm going to draw the player as like a triangle, yeah, I draw it like half and half, right? And what we could do is we could use the other nibble of animation for like when you explode. I just made another case 4. That's the space between the barrier and the player. Again, I can tweak this, but for now, this should work. All right, so for the player, I'm just going to do, I don't know. Well, it's going to be controlled by the paddle, but I'll just do, I don't know, 50 for now, just a static position. Sprite line equals the player graphic, line counter minus 110. Now, I guess the question is this going to still be in the same register? Register 24. If it's not, the draw sprite routine won't work. Oops. Might have to do something different. Well, fortune has favored the foolish. It put this other sprite line definition into the same register 24, and there is our character. Yeah, so as you can see, drawing our character didn't take up hardly any code at all, which is good, because we're going to run out. Well, we have this. We've used this a couple times, a horizontal position thingamadoohickey, and yeah, I think we could turn that into a function, save some space. Yeah, I'll change that into a function called xposition. Okay, void xposition. Oh, since we don't have a primitive defined for it, we have to make sure that we declare this function before it's used. And that's why draw sprite is above main as well. Of course, there'll be a little bit of a jump cost here. Just as a test, if I OR in the 3rd bit into that register before we draw the hero, that should show the hero as exploded on the screen. Yeah, okay, so there's our amazing hero explosion graphic. I know the fidelity is unbelievable, right? Delay microseconds. What's going on here? Let's go to implementation. I think we should replace that with our other delay function we already tried. Let's be conservative with it, right? So bugs is an array in RAM, but it also is taking up program space to define it. So let's see. That would probably be when you start each screen. What do they used to call that? Boards? Right? Remember that? Like, oh, I'm into board whatever. So maybe instead of doing that, in board start, we do for int x equals 0, blah, blah, blah. We could probably assign other things here as well. And then bugs x equals 1, 2, 3, 1, 2, 3, 4, 5, right? That might, well, it might be a wash for how much space it takes up, but we're going to need, you know, some functions in order, like reset the game, make the game over, reset the board. Anyway, yeah, that actually saved us a little bit of program space. Oh man, it's really tooth and nail right now. Well, it should be all right. I think what I'm gonna do, since I pretty much have the main board or the main graphics in place. Oh wait, actually, let's see how much we can save by getting rid of the delay function. So right now we're at 622.15. Well, we probably won't save any RAM, but I bet you we save some bytes. 622. removing the delay function and using XPOS for all delaying purposes instead. It saved us about 8 bytes, which is 4 instructions, but those might be the 4 instructions that we need in order to make this project work. Player X, which is obviously the X position of the player, don't think we really get away from, we got to have that. We got to have that as a variable. So let's read the ADC right there. Notice you go from about, well, you want to go to 0, probably like 20 to 90. For now, let's just make it simplified. If player X, bit shift 1 to the right. So if it's 0 to 255, this will make it 0 to 127. We basically cut off the bottom bit, which would just probably be noise anyway. So, and if it's more than 90, we just cap it at 90. Over here, instead of a fixed position, X position equals player X. Yeah, that's not confusing at all. Everybody got that? All right, well, there's the paddle control. This might make the game too easy. It would be like Neo from the Matrix fighting a sloth, and he'd be like, whoa. Even with the logic, you can start drawing things off the screen, so that's cool. It's time to start thinking about game logic. We also need missiles, and I think I'm going to interlace the screen, although it might not be true interlacing. It might be more like page flipping. I wonder if I could use the analog computer to control status register for this. Maybe just flip the lowest bit. Here we go. Jackpot. ADC control status register B. If a date in ADSCRA is written to 1, the value of these bits select which source will trigger an ADC conversion. Of course, we're triggering ADC conversion manually by doing it in software. And if that's not set, these will have no effect. Perfect. We can use this register for something. Wow, 3 whole bits. Nice. Like I'm either drawing the playfield or the missiles, because I don't have enough time to do them at the same time. Let's try it and see if it makes it too flickery. All right, 3rd bit, which is 04. That means we could use the lower bits for something else. Basically, I have to put everything in this. So it's either drawing missiles or drawing the playfield. We need to draw missiles along with our graphics. So what I did was I'm using this register, which is, I don't know, has something to do with the ADC. We don't need it. I'm using it as an interlace counter. So we're going to take the every other pixel counter and it. So basically every other line, we're either going to draw the playfield or the missiles, but not both. And then the line logic, which is, what happens at line 1, what line 10, whatever, do the VSync, that's separated. So I made these functions. And yeah, it costs a little bit of time to go to these, but it's not a big deal. The missiles is actually simpler. Right now I just have the hero missile. And I have the hero missile, the XY coordinates is in the interrupt compare register, which we're also not using. The XY position of the hero missile is in the IRC 0 high and low register, X and Y. Again, we're not using that function, and that's 2 whole bytes as part of the timer system. So since we freed up a pin, I'm able to use one as the fire button. So I'm just going to click that, and there you go. A missile comes out of the player. Pretty easy. So when the missile is invalid, that's going to be missile value 255. So in line logic, we just use, one of the case statements to evaluate the missiles. So if the missile is not 255, that means it's moving. Move it 2 lines per frame, and if it hits the top of the screen, disable it. The next step is to compare the missile to the array of bug data and see if we've got a hit. Okay, so the hero missile enemy collision, I'm going to draw it on graph paper, otherwise it's not going to make a lick of sense if I just do it in code. I know a lot of times people in the comments say, oh, I have no idea what Ben was talking about, but I watched the whole video anyway. Actually not sure why you would do that, but whatever. This probably won't make any sense unless I draw it out. There are the enemies as they appear on screen, so left, right, top. But in computer memory, they're 6 bytes. So it's 1, 2, 3, 4, 5. Well, 4, 5. And then, the first 3 bits is reserved, right? And then you have your enemies, right? All right, so what we're going to do is, we have to map the relative time delay based screen positions to this grid, all right? So we're going to find the missile relative position here and here. Now notice how it's one space to the right. Now that's for a reason. And I already did a few tests, so I know it's going to be about 25 to, what was it? Now let's just say 85. It's about like that, right? So that's how many NOP cycles it is across. So what we'll do is if the missile position, the missile H position, if it's above the leftmost bug. Kitten, I hung out with you an entire hour this morning. Stop being so needy. All right, so what we'll do is we'll take 85 minus 25, which is obviously 60, right? And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 60 divided by 12 is whatever it is. I should know that because I have all these calculators. The missile horizontal, we'd subtract the bug baseline. So that would give us 0 to 60, like a Tesla. Then we divide that by 5, and that would give us 1 to 11. And that's going to refer to these 12 rows. And remember, every other one is empty. So it'll be like, well, let's just draw a separator. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so obviously there's space between the bugs. So if this resulting value, I guess we could call it missile H course. So that gives us a course position of the missile, basically whether or not it's touching a monster or the open space. And we can label those columns 0 through 11, right? So then what we do, I mean, it's simple logic at that point. We just say, okay, is it an even number? i.e., is it a blank row? If that's the case, then there's no collision possible and we abort the logic. But if it is an even row, then we want to say, okay, well, have we hit a monster, right? So what we can do at that point, like let's say we have the value of 4, right? And the value of 4 in binary is right? So that's 4 in binary. And what we do, now this is the part where the binary magic really happens. We bit shift that 1 to the right, which acts the same as dividing it by 2, right? So it becomes that, right? And then we can, and that's 2, and we can use that as our bug index, right? So if we're on this, course column 4, we divide by 2, and then we see, okay, yeah, we're going to look at 0, 1, 2, that byte of bug data in memory. Yeah, I mean, you can do a lot of cool things with binary, just by the way you lob off bits or where you add them. Speaking of which, so we're going to rotate it this way now. We're going to need a mask, kind of like the same thing we use, to actually draw the bugs. We can call it missile lock. Let's say missile lock, right? And so when the missile vertical position reaches the bottom of the bug array, whether or not the bugs are there, and we'll just take that off. It'll be bug V plus, well, what would that be? 5 plus 50. So once the missile reaches this, then we put a 1 into this position of the missile lock compare bit, right? So what we do is, okay, well, we're here. So, okay, are we on an even row? Yes, okay. So we're going to take this byte. Let's say we're on column 4, which, divides down into byte 2 of the array. Okay, so we compare that byte with our missile lock bit, and if true, we've hit a monster. Then what we do is we have a sound effect or a score, and then we just take this byte and we subtract the current missile lock position, which will clear the bit. And we don't have to worry about it carrying a bit from the bit to the left like it normally would, because we always know a bit is there before we do the subtraction. That just saves us a little bit of math time. And then after the missile has moved 10 more pixels up the screen, we bit shift this 1 to the left, and then we compare the next, well, I guess it would be row of monsters. So we can actually make the collision pretty simple. And then when we start moving the monsters left and right, up and down, we'll already have, set up our collision grid relative to the left-hand side and the bottom, so it shouldn't really affect anything. Basically taking the fine position of missile horizontal and turning it into a course position to see if it lines up with the monsters, and then using that to do the logic if we should hit a monster or not. All right, I put in some code. It's not aligned properly, but oh look, I'm able to whack some baddies.
Interesting. Well, it's not lined up properly, but the general theory is working. Oh, so this, I'm using this to debug. That's a binary number. And right now, that's actually the course vertical missile lock position. So that's actually what it compares with the bug data to see if we hit anything.
That's not good. I've got about, what, 50 instructions left to finish this game? Yeah, no problem. All right, let's animate the bugs, or make them move, I mean. So we already had the animation bit going here, so let's give them a direction. Oh, are there any bits laying around we can use? I just need a bit of bits. Oh, we could probably use the watchdog timer prescaler. I mean, we're not using the watchdog timer. Yeah, that's probably fine. We just need one bit. All right, let's use this as the direction. So if watchdog timer and 1. All right, so 0, 1. Let's make that going right. So if they're going right, then we'll. So of course this will start with 0, but yeah, going right, then we're going to increase until we hit a limit. And if we hit the limit, watchdog timer CSR equals 0. I don't think we're going to have enough space to actually let them, like if you kill half the invaders on one side, that means they can all move further to the left or right. I don't think we're going to have enough space to do that. So this is the part where we're actually evaluating if we've hit the monster or not, and it's pretty much exactly what I drew up on the graphing paper. Yeah, but when we hit the bug, we turn off the bug bit, we turn off the missile. So let's increase the speed and also increment splash. So if we kill all 30 of them, we'll reset the board. Let's see if it works.
All right, looks like the bugs are marching pretty well. Let's see if the right-hand side gives us any problems. Nope, looks like we stopped it just in time. And again, this is all relative to the missile, so all that code should still work. Can they slide into a missile? They should be able to. Let's see. Oh, yeah. Okay, cool. They can.
We're not going to have enough memory to make the UFO, so I'm going to start the bugs further up the screen, maybe like, I don't know, 4. And I was thinking to see if they've reached the barrier or not. We could basically see that, how, we have case 3 for when the barriers are being started. So we had that Sprite line, or the monster line Sprite variable, PCMX, whatever. We could basically say, hey, if this hasn't been cleared out by time we start drawing the barriers, that means the monsters have touched the barriers. That's the easiest way to do that. Okay, so if it's still trying to draw vertical monster pixels when it's also trying to draw the barriers, that means the monsters have reached us and humanity is over. 99.8. Oh, that means I've got 1 instruction left. Something's got to give. I guess maybe the barriers. I don't. But am I even going to save enough space to have the enemies fire missiles back? I might not be able to. What are the barriers? I guess the barrier is just a line. Yeah. So it's draw the super space shield. Maybe as I draw each alien, I should just see if the missile is in that same area, and if it is, I blow up the alien. Well, it kind of works, but just this check here of if, if the beam lines up with the missile, and if we're at the right line counter, then erase the bug and the missile. Look at the huge gap between our aliens now, or bugs, or whatever I'm calling them. Man, that's a pretty expensive operation, and I don't even have it working quite right. The array grid bit shift thing, it does work. It works really well, but it breaks once the bugs get past this part of the screen, and then once it breaks, it requires too much logic to fix. Maybe I could put this logic on the missile side, because the missile is much easier to draw. Now, it's a difficult thought experiment. It really is. Because you have to think about it as scanline basis, not a frame basis. If this is under 8, that means it's being drawn, right? So we could possibly use that as a flag, because it would draw a line of monster sprites, and then it would draw a line of pixel sprites. If you're drawing the missile and PCMSK is below 8, that would mean that you have a vertical collision at least, and then you just have to check for a horizontal collision. Where in the world is Carmen Sandiego? Oh yeah, there we got like blub 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 blub. Can't believe more of you don't remember Carmen Sandiego. It was one of those like edutainment PBS shows in the 90s. Max and I actually had an idea to make a show like that. It would be like really dark. We were gonna call it Math Lords. It would be like it would take place in the 90s, so like have mom jeans and stuff, and it'd be about this kid who discovers he's a math lord. But then it would have scenes like we're going to lose our house. If I have a mortgage payment of $500 and we only have $1,500 left in the bank, how long until we're kicked out of the street? And then there'd be an awkward pause and the mom would continue to cry some more. That's right. 3 months. Don't worry, Mom. I'll figure things out. And then the dad would realize the kid can use the power of math to win at the horse track. So he takes the kid there, and the kid does really well. So then gets dragged into the back office. And there's like this mob guy. How come you're so good at betting on the ponies? I used math, sir. Math, huh? Never heard of it. Then the bad guy pulls out a gun. You want me to grease him right now, boss? And the dad's like, no, no, no. My kid's a math genius. And I think there was going to be a wizard too, and like Princess Decimelia, because there'd also be a magical kingdom where they go to. Yeah, so it looks like we are getting a valid vertical collision. So I guess if we just check for horizontal collision, that might just do it. Oh, there is even a song. When you're inside and there's nothing to do, why not go solve a problem or two? Sooner or later you'll start to find the math is everywhere. The things you do are so exciting. You'll solve those problems fast as lightning. It's all within your reach if you just look inside. You could be a math lord. Don't try to hide. Math is the only way. Be a math lord today. Day. Sorry, I was kind of out of my vocal range there, but you get the point. I don't know. Apparently people like to hear me sing, even if I don't always do it well. So there you go. Okay, so if the horizontal position of the missile is greater than bug H, which means are we in range, then we'll take our, we'll take ICR 0. So we take the horizontal position of the missile and we'll subtract our new beam H variable. So that'll give us the difference between the left side of the monsters and the current position of the missile. Now what we could do, if we could divide that down to make it 0 to 5, then we could look at the bits in the bug graphic register, or not the bug graphic register, but the bug register, and then see if we've hit something. So it would kind of work in the same way as what we did before, but we're just using math, sir. So, who's this kid that comes into my pocket and wins all the money? I've never seen this boy before in my life, sir, because I like the cut of his jib. That's my son! Basically, wishbone with math. Speaking of math lords, I had this backwards. Beam is the missile position minus itself, not it minus the missile position. No wonder I had a negative number. Yeah, I should make a show called Math Lords. Then, let's see. So, yeah, if it's 5 clicks per space, then we would divide this by 5. Thankfully, this is after you've drawn the missile. So if the missile's too far to the right-hand side of the screen, you might run out of time to do this. Then remember before we had that even-odd thing. If beam H and 1, so if it's an odd pixel, nothing happens. So we'll just do if not beam H and 1. So if we're on a vertical line that has a sprite being drawn and we hit a monster, then erase the monster. Let's see if this works. Oh, and then as before, yeah, we would take beam H, divide by 2, and then what was it? Bugs, beam H. Which one did we subtract? I'm not sure, because we have to subtract a bit. But the bits are the verticality of it. We might have to divide that based off the bug V position. Oh man, this is a lot of math. We might run out of time before the end of the line. You know what, just for now, just erase the entire line of bugs. And also kill the missile. Hero missile off. Hero missile journey. Can any of you future math lords spot the problem? That's right. I forgot to make it an assignment. Oops. This is a lot of math to do after a scan line. And if a missile's over on the right-hand side of the screen, you're going to have even less time to do it. I wonder if we could move this off and do it in the vertical blank. How about missile check? Yeah, that's easy. All right, missile check equals 1. See, we're going to run out of program space long before we run out of RAM. So let's just give away RAM now. Of course, we saved a lot of RAM by using registers. It's missile, but we say missile, just like solder. Line logic. Oh well, we have plenty of time. Let's do it while we're drawing the barrier. Why not? Gone beyond the Great Barrier. Is it possible? Excuse me. What does God need with a starship? Not the worst Star Trek movie. It's better than, well, I like it better than Part 3, Insurrection, Nemesis, Into Darkness, which is the worst Star Trek movie. But yeah, I actually kind of like Star Trek 5. There are parts of it that are really good, like the scene in the captain's quarters where Cybok is trying to convince them to go to his side because it's lit like a play, and it's actually a really good scene. He's like, "My God, man, don't make me do this." Because one thing Shatner, okay, granted he's not the greatest director, but he understood better than anyone the dynamic between Kirk, Spock, and McCoy, and that was the heart of that movie. That's one of the reasons, as a character movie, it works pretty well. Shut up about Star Trek 5 and program. That's what the comments below are going to say. So if there's a possibility of a missile collision, so all this tells us is that the missile's on the same scan line, or was on the same scan line as an alien that was being drawn. So it's up to us to use the missile X and Y position, or H and V, to figure out if it was actually colliding with a valid bit of a bug. So all of this should still work. The difference is we need to figure out the vertical as well. So I'm going to go ahead and do another uint, and then I'm going to call it beam V. And beam V, oh no, we will have to have a check for that again. Okay, if ICR 0, so if the missile's vertical position is greater than bug V, that's the same thing we did up here. Okay, then we continue. Basically, we don't want this to continue checking after the missile passes off the top of the screen. All right, so if that's true, then we're going to create beam V, which equals ICR blah, blah, blah minus bug V. So that gives us the difference between the tip of the missile and the top of the bugs, like the top line of bugs being drawn. And then we do the same thing where we take beam V, we divide it by 10, and we don't have, and since they're all in a row, there's no spacing vertically, we shouldn't have to do anything more than that. So then we would do if bugs, bunny, beam H, and beam V, so if there's something there, then we blow it up, and then we turn off the missile. There's one more thing I have to do. So we divide that into a number, but then we also have to bit shift it. So beam V equals 1 bit shifted. Oh wait, actually it's backwards because the monsters closest to the player are the LSB. So the lower the number, the higher we would be. Actually, no, that makes sense. Well, whatever. If it's wrong, we'll just flip it. So, okay. So if beam V became a 5, then it would be 1 bit shifted 5 to the right.
Now the missile disappears too quickly, but other than that, it seems to work.
I just remembered why it's not working. The top 3 MSBs of our bug graphic are not used yet. So really, we should start there. So that's why it was erasing the wrong bug. Oh, where'd that code go? I'm so confused. All right, so we actually need to bit shift that.
There we go. See, the missile kind of goes away. It takes a while to actually get in there. See, that's like... Maybe the alien is tough, and the alien, the creature, the monster, or whatever I'm calling it in this part of the video. It looks like the math is a little off there. I might have to tweak that ever so slightly.
You know, we still need to make the bugs hit the bottom of the screen. See, like, right, see how, okay, that would be the last position. And right there, I would lose, right? Well, I can still get them that low. So we basically have to say, okay, if we're trying to draw bug sprites on the barrier line, then the player has lost. I got to just figure out the simplest way to do that in code.
I basically added a variable called check, and it counts basically how many times we draw an alien. Let's see if it works. It did. See how they're taunting us?
I think we're also getting a debounce issue, so I'm going to make it where you have to wait at least a third of a second before you can press the button again. Yeah, that might be a bit much, but we'll figure it out. So we'll go up here. So actually, let's only do this once. So if not pin B, and so basically if the button is pressed, all right, so if the button, if not, oh, and then also, if not PB, and if the button value equals 0, right, oh, equals 0. Yeah. And the button can only get down to 0 if you release the button. So see, if the button is high, which means you're not pressing it, and the button value has been set, decrement the button. There's nothing else that will decrement the button, so that should work, although, oh man, we're probably going to, is this going to cost us the code we need for a speaker beep? The sounds are going to be very pathetic anyway. All right, so if we push the button, we're either in a game or we're not. So the button either fires your missile or it starts or restarts a game. I mean, okay, so what debounce is when you push a button or release a button, it can have multiple states. Like it doesn't just completely turn on and off. It might chatter a little bit. And so by having a time period associated with that, and also by waiting to decrement the counter by the button being clear, you have a better shot of the button actually working. There's fancier ways you can do it, but again, we don't have the code.
Okay, so if I hold down the button, okay, debounce is working, although we've introduced some other errors. Why is my player doing that?
I figured out what it was. Starting V was being reset to 0 in the game over screen, but it's still trying to draw things on the screen. So what we'll do is we'll take that and we'll go to board start. We'll just do if. So if game state was a game over condition when the button is pushed to restart the game, then we reset starting V to 0. Because otherwise in board start, we increase starting V to make the bugs a little closer to the player each time. Although we should have a limit to how close they can get. We destroy too many pixels. But when we're turning on the missile, if I turn on the LSB, that's the missile. And then, okay, so I'm leaving the second bit 1 constantly with the data direction register. So that should allow us to output clicks or beeps through that pin. Maybe the duty cycle would be loudness, I think. And the frequency would be, well, how often you change it. That's how we perceive it. So we could use the register B compare values, the high and low bytes. That could be like maybe that'd be the frequency or the duty cycle. I think it would be like, maybe we could turn it on and off every pixel, every missile line, and the frequency at which we turn it on and off would make, well, the frequency. Yeah, one would be the counter and the other one would be the period counter. For shame. If that, increment that, and if it's more actual period, it'll be period per line. Okay, so if it's more than the high register, you might think this is confusing. It's confusing for me too. So we're gonna, every frame will set this to 0. All right, so actually let's just do that right now. Ugh. All right, we set that to 0, and then the high one will be, so that's the counter, and the high one is the frequency. Oh no, I'm out of memory. You're tearing me apart, compiler. I'm at 98% program space, and I notice when I get closer to 100, it starts to distort the characters. Might have something to do with the pointers and the flash. Not sure. I think before I can even have a hope of adding even the most rudimentary beeps and bloops, I'm going to have to optimize what I have. I feel like some sort of byte pauper, not a prince. Like line counter equals 0, right? So it's like where's that 0 coming from? I guess the memory? Could we do Erica equals line counter? So it's loading something from RAM instead of flash. We were at 1000 bytes. That doesn't seem to save us anything. Oh, right, because we'd still be specifying what RAM location we want to make. Yeah, shoot. Yeah, I wonder if we could save anything by incrementing this register instead of assigning it to a value. I would still toggle. Oh, wait, no. Eventually it would overflow to the bits that actually matter. It feels like I'm rooting around in the gutter, like, oh, please, sir, I want some gruel. But instead of gruel, I'm looking for bytes. Please, sir, can you spare a bite? You see, I'm a British orphan. I wouldn't give it to you if you were like a Hungarian orphan, but you being a British orphan and all, that changes the tick. Did that save us anything? No, darn it. So it appears that comparing this to 0 or 4 makes no difference. I suppose I could not turn off the missile when we restart the board. Does that save me anything? That saves me 2 bytes. So that could potentially cause a glitch. But now maybe see why people might have glitches, because they're like, oh, it's worth it because I save memory or have a trick somewhere else. Trying to save memory by removing that from board start actually pointed out a different bug, which is if a missile is in motion when the enemies reach the barrier, the game will automatically restart. I'm not exactly sure why the missile is causing a trigger condition, like the button to be pushed, but trying to save memory actually exposed a bug there, so that's good.
I'm going to fire a missile right before they reach the barrier. We'll see if this is fixed. Okay, cool.
The only other thing I can think of is maybe I could use the OCBB on compare match, although I could toggle that pin, which is actually the pin that I reserved for audio. And when the timer reaches A, it's going to reset itself. But it would give me an actual clean waveform. And it wouldn't cost me anything. Okay, so we would want, all right, here's the 2 bits. Toggle it on compare match. Okay, so that'd be combo 0B, or bit 4. Okay, so where's our timer control register? Oh no, we didn't even set anything up on the A register. Oh, okay, so that will cost us a little bit. No, it can't be 10,000 because then it'll never reach it because the timer resets itself when it hits A. Well, I've got the scope hooked up. Let's do 250. So it should trigger before it gets cleared by hitting the A timer, which obviously we absolutely need that one. You gotta fight for your bytes to program.
Here's my amazing audio circuit. I have a resistor connected from PB1 to the base of the transistor. And the transistor will basically allow current to flow through the speaker to ground. It's like the simplest amplifier I can possibly make.
It's outputting a 7 kilohertz signal. You can see there's spots where it's truncated. That's because doing that assembly shift of the sprites will actually affect it. But if we change the prescaler so that we have more granularity and so that we can oscillate, well, 7,000 hertz, I should be able to hear this.
Oh, what a beautiful noise. No, actually it's an ugly noise. Well, I have kind of an awful sounding chorus here. Looks terrible on the scope. It does line up with the movement though. Bud, could you give the sound a review on Yelp? You ready? What do you think? What do your cat ears hear? Yeah, I don't like it either. I do have a sound that is synchronized to the monsters, but I wouldn't call it pleasant. I'm sorry if your dog or cat or pet hedgehog is making noises in the other room, or wife, or husband.
And since the missile seems to be the most affected when I use that pin, I wonder if these registers that we're using, see, this is the input compare register for the timer, and I'm using it for the missile, but I also wonder if maybe that bit is affecting it. I don't think I enabled that though. Blah, blah, blah. Okay, what can we connect to? Analog comparator or input pin. Is that something that we messed with? Input capture trigger source. Okay. Analog comparator control. Okay, we're not using the analog comparator. Although we were using that register to do things. Oh no, we didn't mess. That's the main. Okay, we didn't mess with that. Let's go back up here. Okay, interrupt, programming, blah blah blah. Here we go. ICP 0. So I'm wondering if setting that pin to 1 is triggering some sort of timer thing somewhere else. Yeah, I see that is connected to it. See that? ICP sounds like some playground joke. ICP 0 is connected to TC 0. Oh yeah, input compare. Timers your input capture input. Yeah, did we enable this with all of our rampant bit manipulation? We may have. The input capture register can capture the timer counter value at a given external edge triggered event on either the input capture pin or the analog comparator pin. Although, wouldn't we have had to enable that? Let's see, where is it? Where is it? Time to get this big guy back into action. And let's see, input capture edge select. 0 or 1. When noise cancels activate the input, okay, there's a filter for it. I'm just wondering if it's on by default. That could explain why we are affecting the timer. And the easiest way to fix this would be to just use regular variables for the missile XY. It's weird. I'm surprised that's enabled by default. Oh yeah, see, we've got 13 bytes left, so obviously I can just go through and change all these. I definitely don't want to go through and do automatic find compare, because it might also redefine these in the main AVR files. That would be bad.
Sure enough, that was it. So yeah, I guess we flew a little too close to the sun with using all these extra registers. Although we still have the OCR compare B. Yeah, I guess we just, read the effing data sheet.
Every other frame of alien animation will make the sound of silence, and the people bowed and prayed.
So this is just farting out some beeps while it's drawing the ground.
So I think we have the SMCR, right? And we're comparing it with 08. But if you think about it, what we're trying to do is we're trying to change that bit right there. So I'm wondering if we could AND it. SMRC. So what's 02? I think we're using it as obviously we're using it as a flag. Where else is this? Okay, that's the VSync pulse. Okay, and so what if we swap those? We'll swap VSync with animation. I'm going to basically go through and check. Okay, so VSync is now 8, which is the 4th bit. And where else? Okay, so we need to do it there too. All right. Okay, and the animation bit is now on 2. I think we're using the, well, whatever. This is all that matters right now. Okay, so now we're using the 2nd bit of SMCR for animation. So what we could probably do is port B or equals, oh heck, port B just equals SMCR. Let's see if that works.
Which means it's only making sound at the bottom of the frame, so maybe we can get the missile to do something too. Now that we fixed the problem.
So right now I'm enabling or disabling the missile by having its vertical position be 255. So 255 is disabled, anything less than that is enabled. But if I make it disabled at 0, I think I can save some code. Like right here, if missile V minus equals, so basically if it equals 0, then it's disabled, which means you wouldn't need that, for instance. Then what? Then this is terrible. My idea is just to pipe the value of the missile V into port B. So if it's moving, you should hear some undulations there. And if it's just 0, you won't hear anything.
It works. The only issue is you see the remnant of the old missile at the top of the screen. Just kind of stays there and hides like a possum. Just put a piece of tape over the top of your screen. It'll fix everything.
Yeah, I should be able to fix that. We'll just add a check here. If the missile pixels are active and the missile is active, then draw the missile. Yeah, originally I was calling it a hero missile because the aliens were going to have their own missile, but there were budgetary cuts, and now their only way of attack is to just run right into Earth. I'm using the X position delay to actually make the missile sound different as it flies up the screen. It'll basically get quieter the closer it gets to the top. Yeah, I'm going to try one more thing. I'm going to see if I have enough memory left to make kind of a noise sound when you actually hit an alien. So I think I'm going to actually stop the programming here once I do that, and then we'll move on to the actual assembly of the mini console itself.
I have a potentiometer, which I'm going to use the baseline size, an ATTIny, socketed so we can swap it out. RCA jack, some power switches, Radio Shack perf board. But you know, a tiny console needs a tiny battery. Where could I get a tiny battery? These skyrocketed in price to $11. I was like, I won't pay it. Then I paid it. Hey, you still get like 3 LiPo batteries with this. Oh, there it is. 4 volts. No whackers. I don't even know what that means. I just know that Dave Jones says it all the time. You mean... Oh, I know what I can do. I have a plan, Arthur. I have a plan. I don't think Dutch has a plan. I'm the world's most progressive cowboy. I can draw real good, too. Bend both of the tabs up. That might give us just the room we need. And it did. Yeah, this will work better. Yeah, I want it so you can take the cartridge out, you know. I guess, so really, if you think about it, this is almost like the game cartridge, right? Like, I was also thinking we could use the bottom 2 pins, because these are 2 4 headers, and this is a 3 pins per side. We could use the bottom 2 for like an external charging port. They're just puny ants. You know, it's actually one of my favorite Pixar movies. I really like it. Because, you know, there's like an inventor bug, and it's really just, you know, 7 samurai with bugs, but, you know. They keep remaking 7 Samurai, The Magnificent Seven, Bug's Life, that one episode of The Mandalorian. And then we'll hook up a switch, which will actually send the power from the cell to the chip. Now, the voltage divider for video production, for video amplification, it probably will change with the voltage. The frequency shouldn't change. I think this chip can go full speed down to like 2.7 volts. So we see, you know, they say LiPos are like 3.7, but when you charge them up, they're more like 4.2. Oh, I gotta be careful when I'm soldering these battery tabs, else this is gonna become a tiny Samsung game console. Oh no, are these the kind you can't solder to? Okay, I'm gonna wrap Captain tape around this to keep the terminals from touching anything that they're not supposed to. Yeah, let's see, so I could put this here, so it's like that. Oh yeah, that's what I got so far. Hooked up the ground pin. I also have to hook up the power pin, but there needs to be a switch as well, so I'm not going to do that quite yet. The Ben Heck crappy game system comes with these hit games: Space Invaders ripoff, and many more. Now how much would you pay? I can put this right here. Hello, hot glue, my old friend. I've come to overuse you once again. In the group, Simon and Garfunkel, the one who is not Garfunkel. I'll take anal bumhole covers for 800. There isn't nearly enough hot glue in this yet. There we go. I got a little power switch here. So we've got the 4-volt battery rail there. So if I connect it to the switch, I can go right into the power of the chip.
Let's get a 15 ohm resistor coming from the white pixel, which is 0. Sorry, bud, I'm trying to make the world's crappiest video game console. There we go, we use that for the switched on voltage side. All part of a balanced breakfast. I always think it's funny when they say, oh, it's part of a balanced breakfast, and that's why they show like the cornflakes and the grapefruit and toast. And, you know, so it's like, oh yeah, that's the balanced breakfast. It's like, nobody's gonna eat all that. They're just gonna eat the frosted flakes. Okay, I just need to bridge this to these 2 resistors. Yeah, I could hook up to the scope, or I could just go for it. I've got my camera downstairs here. You know me, I just like going for it. It might actually behoove me in this situation to actually go for the correct values for the voltage on the output and then just put in a little transistor to amplify it for the TV itself. I just slapped a big old 5K pot on it and took it around to different TVs that I had. I actually got it to work on my big living room TV, which is old enough to still have composite inputs. It was one of the first 4K TVs. I'm gonna use, I should have some surface mount transistors around here. Well, I should. I hope I do. It's right here. Okay, so this is the audio pin. We have a 1K resistor going from that to the base of the transistor. Well, hook up the speaker to voltage, then sync it through the transistor. Well, I stand corrected. I didn't have any surface mount transistors laying around. All right, I added an adjustment pot on top so you can tweak it depending on what TV you've hooked it up to. Now I just need to find a speaker. I think this little speaker is just too lame. Ooh, what about this rectangular speaker? Maybe I could kind of like put it like right here. Yeah, it's nice to work on a kind of a ship in a bottle microcontroller project. You know, oops, a project that doesn't really have any real purpose, it's just fun to do. Much better. Look, I can play blindfolded. Oh, this circuit board is clearly extraneous. Let's get rid of it. There we go. This pot has a center click nub, which isn't really conducive to gameplay. I should have realized that before I put it all together, but now I have to deal with my short-sightedness. Well, now I can enclose everything in hot glue. I got this cool knob. Yeah, I think I'm gonna try this on my big TV next. That'll be a good like thumbnail test. Yeah, it looks like something from space. A bunch of instruments just like stuck together, floating through space. Now, Bud, I know you were all excited about getting the PlayStation 5 and I couldn't find one, but I got the next best thing. Look at these graphics, Bud. Can you believe this? I mean, this hero needs Cyberpunk 2077 when you've got graphics like these, where my interlace code doesn't seem to be quite working the way I expected it to, but I couldn't really tell it until I put it on a big screen. But I know you like to talk about 4K. How about like 0.256K? All the interlacing looks like there's a bunch of prisoners coming after me. Oh, I could call this game Jailbreak. Remember the rule of graphics, people. Everything looks better when it's smaller. Well, I suppose for you watching this video, it might not look that much different, but it looks a lot different for me sitting here in front of this TV, which doesn't have HDR, unfortunately. But this was one of the early 4Ks. It cost me a fortune, so I'm going to get 10 years out of it, darn it. Well, there you have it. A tiny little console made with the ATTINY 10 microcontroller. What do you think about that, Bud? It's almost as good as a PlayStation 5. Well, I think I might do a follow-up to this in the future, maybe using the ATTINY 254585. That one has a universal serial shift register function, which will actually make it a lot easier to do the graphics. And maybe Bud can help design it. Look at those paws. He's a Lion King. All right, well, we'll see you in the next video.